The problem given to you was there were 5 consecutive terms in GP. So always you consider those terms as A upon R square, A upon R, A, AR, AR square. Okay. So when you take product of them, you get cancellation of R and you get A raised to 5 is equal to 32, implies A is equal to 2. So this is a quick information that you have the moment you read the problem, and then it is also given to you that sum of them is out common 2 inside bracket 1 over R square plus 1 over R plus 1 plus R square adds up to 211 upon 18. So that means we are supposed to deal with 1 upon R square plus R square plus 1 upon R plus R plus 1 is equal to 211 upon 36. Now the trick here is this is 5th degree equation, but it is very kind equation, kind to us because all the coefficients are 1. It is good, nice looking, and therefore the trick here is put R plus 1 upon R is equal to T, implies R square plus 1 upon R square is equal to T minus 2, and therefore we get
T square minus 2.
minus 2. T square minus, we get T square minus 2 plus T plus 1 is equal to 211 upon 36, which is a quadratic equation. T square plus T minus 1 minus this, so minus 211 plus 36 upon 36 is equal to 0. So the formal quadratic equation that you end up getting is T square plus T minus 247 upon 36 is equal to 0. And then you are supposed to solve this for T because it is quadratic equation. We should be able to solve it, and hence we can write directly T is equal to minus B plus minus under root B square minus 4 A is 1 into 247 6 upon 2A, which is equal to minus 1 plus or minus, what you end up getting is 16 upon 3 upon, which implies T is equal to 13 upon 6 or minus 19 upon 6. That is what is available with us. And T is, so we have to consider both these values of T and get back into R and find out the value of R. So R plus 1 over R is equal to 13 upon 6, implies R square minus 13 upon 6R plus 1 is equal to 0, implies 6R square minus 13R plus 6 is equal to 0, and this should get factorized 6 into 6, 6 plus 6, something like that. Something is happening there, and therefore R comes out to be equal to 6r square minus 12r minus r plus 6 is equal to 0, makes it 6r inside bracket r. काहीतरी चुकतंय का?
Sir, 4 and 9.
तर 4 and 9 असायला पाहिजे.
हो सर.
4 and okay, so square minus 9r plus 4r plus 6 is equal to 0, and therefore मी काय करत होतो, it should get multiplied to 36. 3r inside bracket 2r minus 3 plus 2 inside bracket r minus 3 is equal to 0. Therefore, you get 3r plus 2 is equal to 0, or 2r minus.
If we want minus 3 there, then we need to remove minus 2 from that. Plus 6 नंतर plus 6 च राहील. Plus 3 only.
अच्छा, इथे मायनस पाहिजे नाही का? बरोबर. माझं जरा डोकं ठिकाणावर नाही. ओके, करेक्ट. So it should be minus here also. Okay, and therefore r is equal to 2 by 3 and r is equal to r is equal to 3 by 2. That is one part of the story. Other part of the story is r square plus 19 by 6r plus 1 is equal to 0, correct? Which is 6r square plus 19r plus 6 is equal to 0. And if we solve this quadratic, again r is equal to minus 19 plus minus under root 361 minus 144 divided by 12. Therefore r is equal to minus 19 plus minus radical 217 upon 12. So these are the four values of r, and you were asked to find out r. Now you will be surprised, what kind of common ratio is this? But this is a common ratio. So maybe if the middle term is 2, then there are two common ratios here. Let us call this as R1, this is R2. R3 is equal to minus 19 plus radical 207, 16, 17, 12. R4 is equal to minus 19 minus radical 17 upon 12. Correct? Now, here you observe that they are reciprocals of each other. And therefore, practically this common ratio is giving you the same set of numbers, but once you write them in increasing order and second time you write them in decreasing order. Therefore, there are two different geometric progressions. But essentially you can observe that the common ratio, product of common ratio happens to be 1, and will be the same case here also. The product of these two common ratios will be equal to 1. They are reciprocals. These guys are reciprocals of each other. They multiply together to get 1. You may try it later on, but factorize 6x raised to 4 minus 35x square x raised to 3 minus 35x plus 6. Okay, Now the technique is to be used, which we have used in the earlier problem, but there you had some reciprocals there. So let us convert this equation by taking x square common. We get 6x square minus 35x plus 62 minus 35 upon x plus 6 upon x square. Okay, then take those like terms together. X square continues to be outside, 6 inside bracket, x square plus 1 upon x square minus 35 into x minus x plus 1 upon x. What you are left with is plus 62. Okay, and now we can consider x plus 1 upon x is equal to t, and therefore t square minus 2 is equal to x square plus 1 upon x square. Now we can, for time being, we can consider this t x, let it be outside. We are not substituting this outside x in terms of t, unnecessary, and therefore we will deal with inside bracket on this 6 into t square minus 2 minus 35 into t plus 60, correct, which is equal to, so let us keep this x square outside just like that. It's a 60 square minus 35t, this minus 12 plus 62 is plus 50, and this should be good quadratic equation. Okay, so what are the factors? 50 into 6, 25 into 12. What are the factors? 25,
Sir, 20 and 16.
20 and
20 and
16.
16.
Okay, so x square inside bracket 60 square minus 20t minus 15t. Three t inside bracket 2t, no, sorry, 2t inside bracket 3t minus 10 minus 5 inside bracket 3t minus 10. Therefore, we get x square inside bracket 2t minus 5, 3t minus 10. Okay, now it is time to put t is equal to, so 2 into x plus 1 upon x minus 5, this is first bracket, and second bracket is 3 into x plus 1 upon x minus 10 and x square outside. This is what we have. Okay, so now if I give one x to this bracket and another x to the other bracket, we will get rid of the denominator. So giving one x to one bracket and another to another, we get 2x square. Then we get plus 2 minus 5x plus 2, and we get 3x square minus 10x plus 3. Oh, this is good. This gives us 2x minus 1, x minus 2, 3x minus 1, minus 3. This is the complete factorization of given expression, fourth degree equation.
Sir,
Yes,
sir, I did it by different method.
yes. Next problem is 10x raised to 4 minus 63x cube plus 52x square plus 63x plus 10. Factorize. Okay, 10x fourth minus 63x cube plus 52x square plus 63x plus 10. So this is almost symmetric. Earlier was symmetric. This is almost symmetric. Okay. Let us do this. With little change, we will get the factorization of this. X square inside bracket 10x square plus 10 upon x square minus 63x plus 63 upon x plus 52, which is equal to, which is x square inside bracket 10 comes out. So I have x square plus 1 upon x square, but here if I take minus 63 common, I get x minus 1 upon x. Okay, so let me substitute x minus 1 upon x as t, and therefore x square
Sir,
plus 1 upon x square.
sir, it is 1 upon x minus x.
Why? minus 63 कॉमन काढला आहेत ना.
Yes, sir, sorry.
So x square plus 1 upon x square is equal to t square plus 2. So this is 10 times t square. Okay, let me 10 times x square plus 1 upon x square plus 52. That is your second step. Then you do substitution. You get x square inside bracket 10 t square minus 63t plus 52 plus 20. That is
Plus 72.
This can be factorized. It will get factorized into 4 factors straight away. 2 quadratic and then further 2. So let me write down the answer. 5x plus 1, x minus 5, 2x plus 1, x minus 2, and this x square will disappear. This is what is the factorization of given terms. Because we ended up getting fourth degree equation in common ratio, we finished how to factorize. If the fourth degree equation is good, the good means symmetric or almost symmetric, then how do we factorize? That is what is the technique that we have learned. Now let us go back to geometric progression. We have defined it, we know how it looks. Let us write down AR square. Okay, so what will be the nth term? Geometric progression.
A r raised to n minus 1.
A into R raised to N minus 1.
N minus. This is our nth term. AR raised to n minus 1. Very good. So now we wish to find out summation of n terms in geometric progression. These are n terms. So tell me, how are you going to do it? Because we have found out summation of the terms in arithmetic progression few lectures before. Now it's time to find out what is the summation of terms in geometric progression. When it was arithmetic progression, it was reverse and add. Because the common difference between two consecutive terms was same, reverse and add worked really very well. Here the ratio is same. So add because difference was same. Okay. So what do we do? Slide and subtract. Okay. So what do we mean by slide and subtract? By slide and subtract, we mean multiply both sides LHS as well as RHS by common ratio. RSN is equal to, first term would become AR, second term will become AR square, third term will become AR cube, and nth, n minus 1th term will become AR raised to n minus 1 plus AR raised to n. Second last term will be AR raised to n minus 2. After getting by R, it will become AR raised to n minus 1. In the last term, after getting multiplied by R, we get AR raised to, and then subtracting 2 from 1, we get 2 minus 1, we get LHS. R minus 1 times Sn is equal to A, 2 minus 1. So minus A, AR minus AR, gone. AR square minus AR square, gone, gone, gone. What remains is plus AR raised to n. And therefore, Sn is equal to A common inside bracket R raised to n minus 1 divided by R minus 1.
So this we can also prove that 1 plus r plus r square plus r cube and all is equal to r raised to n minus 1 upon r minus 1.
Yes, but then we have done it in.
Yes, sir. Functions.
This is the first. Yeah, this is the first thing that we should do, and we should use this while writing
Yes, sir.
functions. Yes, you are right. So A inside bracket 1 minus r raised to n upon 1 minus is same as this. Normally, if r is greater than 1, you use this formula, first one, and if r is less than 1, you use this. Now, see, we have to be alert here because we are putting something in the denominator. If 1 minus r is not equal to 0, that means r is not equal to 1. This formula is true when r is not equal to 1 because you will be in trouble. But for r is equal to 1, adding them is very easy. So it is okay. It is okay. So this is the formula if r is not equal to 1, and if r is equal to 1, then our geometric progression itself, Sn we want to find out, will be a plus a plus a plus dot 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 plus a how many times?
N times.
N times a. That is what is going to be summation, which is going to be very easy. And therefore we can do two when we are putting r minus 1 in the denominator. R should not be equal to 1. Very important. Now, reverse and add for arithmetic progression, slide and subtract for geometric progression. Okay. Now, let us observe if the common ratio R is equal to say 2 by 3, which is 0.67. Okay, then this is, and suppose there are 100 terms, we want to find out S100. First term is, let us say 1, whatever, easy, any first term can be any. So S100 would be the formula, first term A, whatever that is, into 1 minus 0.67 raised to 100 upon 1 minus 0.67. This is what is going to be the summation of first 100 terms of geometric progression with common ratio 2 by 3. Now, if this is 2 by 3, what will be R square? 4 by 9. And 4 by 9 is approximately equal to 0.44. R cube equal to 8 by 27, which is equal to approximately 0.296. And if you write R raised to 6, which you can also check, it is 64 upon 729, which is approximately equal to 0.088. So 6 power of this common ratio is very, very small, and this quantity is being subtracted from 1. So your calculator will not be able to find out this 0.67 raised to 100 because it is very, 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 very close to 0. Still it is 100. If it is 1000, for all practical purposes, we can consider it as a 0. So if, what I am trying to tell you is, if mod r is less than 1, that means common ratio is between -1 to 1, and if number of terms is tending to plus infinity, that means number of terms are very large, then r raised to n tends to 0. Now this is calculus. As n tends to plus infinity, r tends to 0 is calculus, which we have not learned yet, but we are trying to experience what is happening there. We are not allowed to write equal to at the moment unless we create some definitions. But we are trying to find out what is the solution of the problem. At the moment, I am interested in solution. And at appropriate time in 11th standard, I will correct this theory. As n tends to, if n is very, 100 is a very small number. If I take 0.67 raised to 1000 lakh, it is for all practical purposes, it is 0. It is equal to 0. Calculus will allow us to say that it is equal to 0. It is tending to 0. And therefore r raised to n will tend to 0, and our formula will become further simple. If mod r is less than 1, then Sn, as n tends to infinity, equals a upon 1 minus r. Okay, questions? A ball is dropped vertically downwards from the height capital H above the ground. Its initial speed is 0. The elastic properties of the ball are such that after hitting the ground, say at point G, the ball bounces back to 3/4 of the height it is dropped from. Suppose it is dropped from the point A0. After one bounce, let A1 be the highest point the ball attains. After one bounce, let A2 be the highest point the ball attains, and so on. So A0G is equal to H. A1G, A2G, A0G is H, A1G is 3/4 of H, etc. Compute the total distance traveled by the ball till it comes to rest. It is very simple. From A0 dropping it goes to ground. So this is your first edge. Then it bounces back 3/4. Oh, 3/4, yes, and comes back again. Now it will happen on exactly on the same point, but just to understand, I am doing it. This is 3/4 of h two times. Na? H is one time, 3/4 of h two times. Then 3/4 of 3/4 of h is going to be again two times, and so on. So maybe you can calculate this also two times. 2 times h plus 3/4 of h plus 3/4 of 3/4 of h plus so on. This is what is the total distance as traveled, and you need to subtract one h from this. That is what you remember. Then h also comes out common. So 2 inside bracket 1 plus 3/4 plus 3/4 square plus 3/4 cube plus so on. Now this 3/4 is our common ratio now. This is geometric progression inside bracket. Okay. And therefore 3/4 is our common ratio, and therefore summation of the terms 3/4 is between -1 to 1, and whenever this is dot dot dot, it is tending to infinity. So the ball is going to be like this actually it is going to be endless bouncing, it will take place, and eventually we say that it has come to the rest, but practically for theoretical purpose it is still bouncing. Okay, anyway, so first term is 1 divided by 1 minus 3/4 into 2h, which is equal to 4 into 2 8h, and therefore required answer is 8h minus 1h is equal to 7h. Okay, and therefore while writing generating functions also, we wrote generating function for 1 plus x square plus x cube. Now suppose we stop here, we wrote generating function as x fourth minus 1 upon x minus 1, something like this. But if we are not stopping, 1 plus x square plus x cube plus dot 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 dot, what we wrote is 1 upon x 1 minus x, or x minus 1 minus x. This is the generating function that we have written, which is actually the summation of infinitely many terms in GP with common ratio x, and here we are supposed to write that -1 is less than x is less than 1. Then and then actually it is true. Otherwise, generating function for this sequence, if x is greater than 1 or less than -1, this is not true. This is not true. It is true only for this -1 to 1. Okay. Again, explanation of this we will learn when we learn calculus, and it is available there in detail. Okay, so that is what is summation of terms in geometric progression.
Sir, can you just scroll up the screen a little bit?
Why did we did -1h?
Thank you, sir.
Because initially ball was thrown from the top, and it was not thrown from the ground like this. It was not thrown like this. It was thrown from the top.
Yes.
Let a comma b be positive real numbers. Positive. Capital A is called arithmetic mean. which is a m of a comma b if and only if a comma b form an AP. So basically, therefore, a minus a is equal to b minus a. Therefore, 2a is equal to a plus b. Implies a is equal to a plus b by arithmetic mean is summation of all the numbers. Here they are 2 divided by number of numbers. Okay. Next. G is called geometric mean. GM of a comma b if and only if a g b form GP, which means G upon A is equal to B upon G, which is equal to, which implies G square is equal to E, or G is equal to radical AB, geometric mean, arithmetic mean. Third, these are definitions. Third one, H is called harmonic mean. Of a comma b if and only if 1 upon a, 1 upon h, 1 upon b are in AP. Reciprocals are in AP. The series is called harmonic mean progression. Okay, harmonic mean. So if reciprocals are in AP, then series is called harmonic series or harmonic progression. Okay. So what do we get over here? Algebra. What is the algebra? 1 upon h, 1 upon a, 1 upon h and 1 upon b form an AP. Therefore 1 upon h minus 1 upon a is equal to 1 upon b minus 1 upon h, implies 2 upon h is equal to 1 upon a plus 1 upon b, which implies h is equal to, maybe I can write this as a plus b upon ab. H is equal to 2ab upon a plus b, harmonic mean. So if you have been asked to find out harmonic mean, the procedure for finding harmonic mean. 1. Take reciprocal. 2. Take average. 3. Take reciprocal. Okay. Suppose you are told to find out harmonic mean of one, not, let us not take 1, 2, 3 and 5. Find harmonic of 2, 3 and 5. What we are supposed to do? Harmonic mean. Let us write harmonic mean letter. 1 upon 2. Take reciprocals. Take average. This is reciprocal and average. First two steps are done. And then take reciprocal. So harmonic mean of 2, 3, 5 is going to be this number. If we simplify, 15 so 5 आणि 3 8 10 5 आणि 5 10 भागिले 30 गुणिले 3 बरोबर चाललंय 1/9 is equal to raised to -1. Is it right? Harmonic mean of these numbers 5 आणि 5 10 भागिले 30 गुणिले 3 म्हणजे 1. Yes. So harmonic mean of 2, 3, 5 is 9. Take reciprocal. So harmonic mean of B, harmonic mean of A and B is take reciprocal, take average, take reciprocal, which is 2AB upon A plus B. This one. Okay. Good. I will wait. So one should not make hurry while doing calculations. This is 15. One should not be in hurry. 15 plus 10 plus 6 upon 90. At least this 90 is correct now. Yes.
Yeah.
So now this is 21 and 10, 31 upon 90 raised to -1 that is equal to 90 upon 31. That is the harmonic mean of 2, 3, 5. Correct? Okay. Cheap. So I was surprised when I got it 9, but somebody said yes, calculations are correct because mean is supposed to be in around those numbers. It cannot be so high. This number is around those numbers. In fact, it should be between because all of them are positive numbers. The means should be between them. Anyway, okay. Next,
So what do we mean when we say harmonic mean of three numbers?
what do we mean by that?
Yes, sir.
I will tell you the application tomorrow. These are the definitions right now, but in real life we have the applications of these numbers, which I think we will do tomorrow because I am left with 18 minutes now. So we will look at those meanings of those tomorrow. One more thing I would like to define here, even if it is not in lecture note, is what letter should I use? R. R is called root mean square of A comma B if and only if R is equal to radical A square plus B square upon 2. Root of mean of squares. Root means square. Root of means of squares. These are the values which are important in statistics. Statistics. Like we know the meaning of average. That is arithmetic mean. We use it in what is the class average, what is the average percentage that you get, etc. So all these means have a lot of application in statistics, another branch of mathematics. However, presently we are just going to get introduced to them, and tomorrow we will see geometric applications of them.
So the sum of the harmonic means of, like, if you consider the one.
Okay, just to give you an algebraic idea about how to calculate harmonic mean, I took these three numbers, but I am not supposed to take these three numbers. I should take three numbers. Say, let us say 2, 3 and 4 are in arithmetic progression. So I should have told you to find out harmonic mean of 1 upon 2, 1 upon 3 and 1 upon 4, not 1 upon 5. Okay, because they need to be, after taking the reciprocals, they need to be in arithmetic progression. Okay, so maybe this is the correct example which I should have taken, but the procedure I wanted to explain, and now it is simple, because you take the reciprocals first, add them, 2 plus 3 plus 4, take average and then take reciprocal. It is easy, which is no, so 3, so 1 by 3 is your harmonic mean. Is it correct now? If I give you
Yes.
these three numbers, then 1 by 3 is a harmonic mean of these three numbers, 1 by 3. Correct. But I will check whether this term is typically used when the reciprocals are in arithmetic progression or not, or it is used in general. Given a set of numbers, find the harmonic mean of them.
Sir, but by using h is equal to 2ab upon a plus b, it does not comes.
Hmm? Yes, it has come. Here you mean?
Yes, sir.
Yes, we have got this formula because the reciprocals are in arithmetic progression. But if it is more than, if it is 2, then it is fine. I mean, two numbers. But if it is two numbers, we can always find out harmonic mean, so that the three numbers which we eventually get, if we take reciprocals of them, we get an AP. So for two numbers, this is fine. But if it is more than two numbers, then the mean has got average meaning in that. Okay, I will cross check whenever harmonic mean term comes, is it necessary that all the numbers given when taken reciprocal form an arithmetic progression or not? For 2 it is true, but for more than 2, whether it is true or not, I will check, because I remember having found out harmonic mean of given numbers. They will not be in harmonic progression. I will check and get back to you next lecture.
Sir,
Hmm.
sir, but even
Show that A is always greater than or equal to G. A is A plus B upon 2. We are supposed to prove question mark root AB. Now A, B are positive numbers, so okay, we are not doing anything. A plus B is greater than or equal to 2 root AB. Question mark. Everything is question mark. So A minus 2 root A into root A root B plus B is greater than or equal to question mark 0. Oh, good. Then this is perfect square. Okay, this is perfect square of root A minus root B bracket square. Is it question mark greater than or equal to 0? Oh, no question mark. It is always greater than or equal to 0. Square of real number is always greater than or equal to 0. Fundamental thing on which the entire inequality is dependent. Hence, AM is always greater than or equal to 0. That is where we are going to stop for the day. I am going to send you a lecture note where you have some problems for practice.